Hello students, welcome to your video lesson on lesson 4, 3 and 4. And we're doing two lessons in one today just because they're both really short. We're just looking at properties of special parallelograms. Okay, in section 4.2, we were looking at properties of parallelograms, like about their angles and about the diagonals and the side length and things like that. And today we're going to talk specifically about three more specific and more special types of parallelograms, okay? And those are rectangles, rhombuses, and squares. So section 4-3 is simply about rectangles. Now, a rectangle is something I'm pretty sure we are all familiar with, okay? It's a shape that looks like that. And we're just basically going to look at one extra property of a rectangle, okay? One thing that we do know about rectangles is that rectangles have 4 90-degree angles. Okay, that is part of the definition. That is truly the definition of a rectangle. So each of these corners needs to be a 90-degree angle, right? A little box like that. And that's, like I say, just something that we sort of already know about rectangles. They have 4 90-degree angles. What we may not know about a rectangle is that if we were to draw the two diagonals of a rectangle, one here from A to C and the other from D to B, if we draw those two diagonals, they have to be the same length. Okay, if this is going to be a rectangle, they have to be the same length. So what that means basically is if the distance from A to C is, let's say, 10 inches, the distance from D to B has to also be 10 inches, and that's sort of what I've put over here, okay? If AC is 10, then DB is also 10. Now, it's important to remember that rectangles are special parallelograms, and so all the properties of parallelograms also apply. The most applicable one for us is that the diagonals of a parallelogram, remember, bisect each other or cut each other in half. And so the distance from A to Z, right, from the corner to the middle here, if let's say that's 12, well, then this other part over here also has to be 12 because this point Z is supposed to cut that diagonal in half, which means the distance from A to C all the way across is 24. Okay, but if the distance from A to C is 24, then D to B is also 24, right? Because that's our property of a rectangle. And then each of these pieces has to be half of that as well. So each of those is also 12. So all 4 of these pieces have to actually be the same length, okay, when we have a rectangle. So most of your practice problems is just about lengths of the diagonals in a rectangle and understanding that that is always true if we know the shape is a rectangle. Now, section 4-4 is about rhombuses and squares. Okay, and a rhombus is a parallelogram that has 4 congruent sides. So this one could be a little bit slanted, but it looks something like this, okay? Where this length is the same as this length, and it's the same as this length, and it's the same as this length, okay? Parallelogram with 4 congruent sides. We don't know anything about the angles until we get to our properties, and then we'll talk about those a little bit. But the definition of a rhombus is just that it has to have 4 congruent sides. All sides have to be congruent or equal in length, okay? Now, when we have a rhombus, we know 2 things, okay? There are 2 extra special properties about a rhombus. So here I've drawn one for us. Here's a rhombus, and there are 2 properties, like I said, that we know to be true about a rhombus. Number 1, the diagonals have to be perpendicular. So if I were to draw the diagonal from this corner up to this corner, and then the one from this corner down to this corner, those 2 diagonals have to meet at a 90-degree angle here in the center, okay? Has to be a 90-degree angle. Now remember that this is still a parallelogram, right? A rhombus is a special type of parallelogram. So again, we have these diagonals cutting each other into 2 equal pieces. So, you know, this piece here has to be the same as this piece here, and then this piece is the same as this piece. But clearly in a rhombus, one diagonal is longer than the other, okay, in one of these slanty rhombuses like this. So it's not true that the diagonals are the same length, but they do have to cut each other into equal pieces, okay? The other property of a rhombus is that each diagonal bisects two of the corners. Okay, when we say bisect, hopefully you remember what this term means. Bisect means to cut in half, right? Bisect means to cut into two equal pieces. So this diagonal from the bottom left corner up to the top right corner cuts each of these angles into equal pieces. So I'll say like angle 1 and angle 2 here, those have to be congruent. Okay, the same with angle 3 and angle 4. Those have to be congruent to each other as well. And then the same thing is true of the other diagonal. The other one cuts these corners in half. So I'll say angle A here has to be the same as angle B right there. And then down here, angle C has to be the same as angle D. Okay, so these angles on either side of the diagonal have to be equal. Okay, so they've been cut into equal pieces. Also remember that because this is a parallelogram, this top left corner is congruent to the bottom right corner total all put together as well. So A, B, C, and D are actually all four have to be the same measure. A, B, C, and D. The same with 1, 2, 3, and 4. These four angles have to be the same measure as well. Okay? So that's our two properties of a rhombus, both about the diagonals. The diagonals have to meet at a 90-degree angle, and they have to cut these corner angles into equal pieces. All right? And then the last shape we're going to talk about is a square. Okay, and a square is a parallelogram that has four congruent sides, and it has four right angles. So I want you to think about what that means. For it to have four congruent sides, and for it to have four right angles. Four congruent sides and four right angles. Well, isn't a parallelogram with four congruent sides a rhombus? That's what I just wrote down right here, right? And isn't a parallelogram with four right angles a rectangle? So we just wrote down right here, right? So a square, you guys, really is a parallelogram that is both a rhombus and it's a rectangle. Okay, a rhombus and a rectangle. So the square then, you guys, has all the properties of both the rhombus and the rectangle. All right, so if we go down here, squares have all the properties of rectangles and rhombuses. So squares obviously have two diagonals that are congruent because that was our property for rectangles. Okay, so again, it is true in this case that the distance from A to C has to be the same as the distance from D to B. Okay, those two diagonal lengths have to be the same. It is also true that the diagonals have to be perpendicular, and it's also true that the diagonals have to cut the corners into equal halves, okay? So if we think about what that means, each corner is 90 degrees, right? Because it's a rectangle, right? So it has to have four 90-degree angles in the corners. And then this diagonal is supposed to cut those corners in half. So these angles are each half of 90, which is 45. Okay, but then the same is true in all of these corners. So all of these angles, you guys, every single one in these corners, once we draw in the diagonals of the shape, they're all 45s. 45, 45, 45, 45, 45. They're all 45. Okay? So you have a couple problems about the angles and maybe the diagonals in a square. Just remember that everything that's true about rectangles is true about squares. Everything that's true about rhombuses is also true about squares, okay? That's really it for this video, just looking at these properties and identifying different missing lengths in rectangles, rhombuses, and squares. So if you have any questions about any of these properties or how these shapes relate to each other, please reach out to me somehow. Otherwise, that's all I have for you, and we'll talk to you soon.